Hi, everyone. Thanks a lot for joining us today. Today, we'll be covering 5 secrets to unlocking the power of Kubernetes. I'm joined with my colleague, Jeremy. Jeremy, how's it going today?
Hey, doing well, Ralph. How are you?
I'm doing really well. Can't complain. Now, before we get started, let's just go ahead and do a quick round of introductions.
I'll introduce myself. I'm Jeremy Desatel, head of solutions architecture here. I've been here almost 2 weeks now, so basically a veteran. Prior to working with Devtron, I would work for Spot.io, Spot by NetApp, and GitLab.
Okay, great. And hi, everyone. I'm Ralph. I'm the VP of Americas here. Prior to Devtron, I've worked for a lot of organizations that were in the application development and underlying infrastructure, orchestration, management space for the last 13 to 15 years. So this space is definitely very close to my heart. And wanted to just give you some tidbits here. A little bit of like, did you know? One organization I was with was CF Engine, and actually some of Kubernetes' key characteristics were rooted in Mark Burgess's principles on self-healing and fault-tolerant systems. It was pioneered by CF Engine, which was an open source project that really affected a lot of infrastructure as code companies. Puppet, Chef, Ansible came out of that. As the same thing, Kubernetes also does the same um, as far as being principled on self healing and fault tolerant. Now, just to give more context, we wanted to go through the different phases of deployments. And so early on, organizations ran applications on physical servers, as everyone knows. There was just no way for to define resource boundaries for applications in the physical server, and this caused resource allocation issues. For example, if multiple applications ran on the physical server, there would be instances where one application would really hog up most of the resources, and as a result, the other application would underperform. So a solution for this would be to run each application on a different physical server. But of course, this did not scale very well as resources were underutilized. And it was expensive for organizations to maintain so many so many physical servers, as you can imagine. And then, of course, the next era came around the 90s and 2000s, virtualization as a solution, and especially spearheaded by VMware, it allowed you to run multiple VMs on a single CPU. Um, and virtualization allows applications to be isolated between VMs and provided a level of security, as the information on one application can't be freely accessed by another application. So VMs allowed better utilization of resources in the physical server and allowed for better scalability because an application can be added or updated easily. And that of course reduces hardware costs and much more. With VMs, you can present a set of physical resources as a cluster of disposable virtual machines. So with each VM, it's a full machine running all the components, including its own operating system on top of the virtualized hardware. And now, obviously, we've come to the modern era, the container deployment era, what we're here to talk about today. And so containers are very similar to VMs, but they have very relaxed isolation properties to share the operating system among the applications. So therefore, containers are considered very lightweight. Similar to a VM, a container has its own file system, share of CPU, memory, process space, and more. As they are decoupled from the underlying infrastructure, And this is the key part to remember. They're portable across clouds and OS distributions. Now, containers have become very popular because they provide extra benefits on top of that, such as continuous development, integration, and deployment. It provides reliable and frequent container image builds and deployment with quick and efficient rollbacks. And this is really due to image immutability. I have a hard time pronouncing that. Jeremy, can you say immutability very quickly?
Immutability.
That's pretty good. So I'm going to get you to say that word next time. But with containers, dev and ops, the separation of concerns are pretty clearly lined up, and so you can create an application container image at build and release time rather than deployment time, and thereby decoupling applications from their infrastructure. And then, of course, just from an architectural standpoint, loosely coupled, distributed, elastic, liberated microservices. Applications are broken into smaller, independent pieces and can be deployed and managed dynamically. So, not a huge monolithic stack running on one big single-purpose machine. And then, of course, there's resource isolation. It's very predictable application performance, and then resource utilization, so high efficiency and density. And here you can see, the growth of the number of machines and the time it takes to deploy, the elasticities. So, of course, today we'll be covering the 5 secrets to unlocking the power of Kubernetes. But this really just shows you the power of Kubernetes, and how it's been accepted as the standard for orchestration of containers. It automates, deploys, scales, and manages them in production. So, and with that, I'll go ahead and give it to Jeremy.
Yep, absolutely. Thanks, Ralph. So, before we hop into the secrets of unlocking the power of Kubernetes, let's just level set with a few of the already well known benefits that Kubernetes is going to bring to the table for us. The first, service discovery and load balancing. So, Kubernetes is able to easily expose a container in your environment using its DNS name or its own IP address. If traffic to a particular container is high, Kubernetes is able to load balance that and distribute that traffic across replicas of that application. This will ensure that stability within that deployment and give you high availability. Automated rollouts and rollbacks. So you are describing the desired end state for your deployed applications when you leverage Kubernetes. And Kubernetes will be able to change the actual state to the desired at a controlled rate. You can automate deployments, and whenever you remove existing applications, if you're adding labels, removing labels, Kubernetes can automatically roll out those updated specifications to your containers. Automatic bin packing. This is also sometimes called Tetris scaling, but effectively, one of the benefits of containerization is being able to better utilize the underlying resources within the nodes or instances. And so Kubernetes, based on the amount of resources you tell it that your application needs, it is able to find the appropriate amount of storage, of compute, of memory to place that container. Self-healing. This is another benefit that comes with declaring your desired end state. And so if you're declaring, I need 3 containers of this application running at all times, if one of those containers were to, error out and shut down, Kubernetes will automatically be able to replace it. It can kill containers that don't respond to a user-defined health check, and it doesn't advertise them to clients to receive traffic until they are ready to serve that traffic. And then fifth, we have secret and configuration management. So Kubernetes will allow you to store and manage sensitive information, whether that's passwords, things like SSH keys or OAuth tokens. And you can deploy and update these secrets. You can update application configuration without rebuilding your images and without exposing that within your code. So these are just a few of the known benefits today. Wanted to level set there before diving deeper. Back to you, Ralph.
Thanks. And before we get into the five secrets, I think it's important to note the current state of Kubernetes. So Kelsey Hightower has been an amazing evangelist for the open source community. And I don't know if you've heard Jeremy, but he announced this week that he's retiring, which of course makes me a little sad. But where people get so he made a post actually, and I think I can probably create several decks just based on his tweets. But Kelsey did mention that where people get into trouble with Kubernetes is when they start cosplaying a cloud provider and going overboard with operators just so they can attempt to run everything in Kubernetes. So, Kubernetes allows you to declare your infrastructure concerns, including your storage requirements, load balancing, service discovery, enough extension points to integrate your policies into the platform itself. And this is clearly 10 times better than what enterprises were doing previously. But the problem is that we ask developers to do all of that. Kubernetes is not a tool for developers. They can use it, but we have to be honest. Kubernetes is a very low-level infrastructure system and works best when people don't know it's there. And so, the whole you build it, you run it, and then shifting YAML left was a mistake. And I think this is a really key observation by Kelsey. The problem is we ask developers to work with Kubernetes. And this is a big reason why there's been such a focus on platform engineering in the last few years. At its core, it's really trying to hide this low-level complexity away from developers so that they can really focus on their core competency, which is just code and business logic.
All right, so the 5 secrets to unlocking the power of Kubernetes. So if we were to unpack that a bit, what are we referring to when we talk about 5 secrets, and what is this power that we're trying to unlock? These secrets are going to be things that maybe you're not considering or implementing, or maybe don't want to implement day 0, day 1. And what is unlocking the power of Kubernetes? I think the quote that Ralph just shared says it great, but it works best. Kubernetes works best when people don't know it's there. It's incredibly powerful, but it's also incredibly complex. And so, if we can implement best practices by leveraging automation and the tools that are out there, then we can really unlock that power. And here's 5 secrets to do so. So, the first one we're going to talk about is secrets management. So if we go to the next slide, what is a secret anyway? Well, like we spoke about before, it's really any sensitive data. A password, a token, or a key can all be a secret. And so otherwise, without using Kubernetes secrets, you might put that within the specification of a pod. You might place it within, a container image. But using a Kubernetes secret means you don't have to include that in your actual code. It can be created and managed independently of the pods that need to access that secret. So there is less risk of not only the secret, but its underlying data being exposed. Now, although that's great, there are some problems and shortfalls if you use secrets that way. So Kubernetes secrets by default are stored unencrypted in etcd. Anyone with API access could retrieve that secret, modify it even, as can anyone with access to the underlying storage. Also, anyone who's authorized to create a pod in a namespace can then use and access that namespace to read any secret there. and even indirect access, like the ability to create deployments. So, what are the solutions? Well, if you're going to use Kubernetes natively if you're going to use secrets natively in Kubernetes, at the very least, you should do a few things. You should enable encryption at rest. You should enable or configure your RBAC rules with absolute least privilege access to those secrets. And you should even restrict secrets to or the access to them to specific containers. Now, that will help, but that is incredibly cumbersome and complex. It depends greatly on the number of clusters you're managing, the number of users that need to, access those clusters, and so it's not going to be very efficient. Another option to strongly consider, and in my opinion is somewhat considered best practice, would be to use an external secret management tool. For example, AWS Secrets Manager. By leveraging an external secret manager, things like key rotation is handled automatically. You can give users read only access to the external secret manager objects. This way, they're able to see what keys need to be used for their application and leverage that without actually having to access the underlying value of the secret itself, effectively eliminating the possibility of compromise. So that's our first secret, actual secret management. Our second one is going to be access control. Now, access control can get quite complex in general, let alone in Kubernetes. And today, there's quite a few challenges or problems there. Again, the first being that complexity. Kubernetes has a complex architecture. There's many different components. And so managing and configuring access policies in a dynamic, distributed, constantly evolving environment can be challenging. The second challenge, it's also a pro, but it's a challenge, and that's granularity. Kubernetes does provide fine grained access to controlling through RBAC, specific roles and permissions for different resources, but defining and managing those can get out of hand, especially in large scale deployments or environments where you have many different clusters, many different users, different teams, different applications. Also, role explosion is another term. RBAC roles are created at the namespace level. So as the number of namespaces increases, I've seen companies where every user had their own namespace, but as those namespaces increase, the number of required roles and role bindings also grows. That leads to what's called role explosion, and that becomes very difficult and error prone in management. Lack of default secure configurations. So Kubernetes does not enforce secure defaults out of the box, which means if it's very easy to misconfigure something, and if done improperly, can lead to lots of vulnerabilities. Continuous authorization. This is another problem with access management in Kubernetes, and it's whenever access is granted, that access doesn't have to be authorized in a continuous fashion. Until that access is revoked, it's enabled. So access requirements changing frequently, like logging in, logging out, that can be very difficult to manage all within Kubernetes. Um, External identity authentication integrations. So Kubernetes itself, although it supports RBAC, it doesn't manage users. So it expects you to have another user management or authentication mechanism to plug in. So you're already having to use that, and managing roles and access within Kubernetes isn't as beneficial at that point. And then lastly, auditing and monitoring and auditing access for all different activities. It can be done to an extent within Kubernetes, but it's not extremely comprehensive. And you typically need to connect additional tools, implement additional processes for that to work anyway. So, what's the alternative in terms of access control? There's many different identity and access management tools provided, both cloud provider specific, as well as ones used for on-prem, or ones that are cloud agnostic. Highly recommend looking at the tools if you are in the public cloud today. Looking at one of the cloud provider managed tools, as they make it very easy to integrate with managed Kubernetes clusters. And so our third secret is going to be Helm in dev and QA environments. Now, what do we mean by that? Well, we've talked about how our lives could be made easier by certain aspects of our infrastructure being kind of abstracted outside of Kubernetes. But this is an area where something that might typically be handled outside of Kubernetes today could benefit from being brought into the cluster. And so, one thing here that comes to mind is allowing developers to deploy, especially open source Helm charts, more freely in lower environments. Typically, that today is handled by platform engineering or DevOps teams. And so, there's a lot of back and forth communication. What this allows is really for us to better implement the values of DevOps, right? If you're a developer, by default, like my boy Ricky Bobby, you just want to go fast. And so this allows you to think about security, to think about governance, whereas it allows the more of the DevOps or the back end infrastructure engineers to give up that control while still maintaining security and governance concerns, and making sure you're having a security best practice implemented. So allowing developers, perfect example would be something like a database or a messaging queue. Instead of that developer having to get access to the database, get users provisioned, put the data into the database, or ensure that all the networking is in place to connect your Kubernetes cluster to the database. Allow them to deploy a database in a container, a Postgres container. This will greatly increase the speed of the developers. It'll allow for iteration at a tremendously improved rate. And again, it just removes those inefficiencies that are caused by all the back and forth. For the DevOps and platform teams whose blood pressure might be rising, thinking about giving up that control, you're still able to predefine effectively like a service catalog, an application catalog. This way, certain parameters, certain security concerns, certain tagging standards can all be enforced while still giving that freedom to the developer. Those guardrails can stay in place. So that's for the third secret, Helm, allowing developers to freely deploy in dev and QA. Ralph, I think you've got a little tidbit for us here.
Yep, I do. So, did you know, Jeremy, that there was stiff competition primarily between Kubernetes, Mesosphere, and Docker Swarm? This was roughly around 2015, 2016, 2017. They battled it out to see which system would be the standard bearer for container orchestration. And it looks like Kubernetes won the battle. And there's a few reasons for that. I think the fact that Kubernetes was able to scale at Google, because of course this is the origin of Kubernetes was at Google. And then CNCF, the Cloud Native Computing Foundation, provided the launching pad for startups and big enterprises alike to fill in the blanks that were left blank by Kubernetes. And so it was really interesting because whenever you think about competing products, you think about competing products in the sense that typically the ones that have the quickest time to value generally win out. The ones that are the easiest to use for users. And Mesos really had that reputation at that time. They positioned themselves as the data center operating system, but Google just had a lot of clout during that time, and the fact that Mesos was written in C++ also didn't help their cause. Google's Go language was on the rise, and it was attracting 3 times more the open source contributions in 2017. So that's a little bit of history for you, Jeremy.
Yeah, back in 2015, 2016, if those containers weren't referring to Tupperware, I probably didn't know what they were.
Right, nice, nice. So now going back to the five secrets. Another secret we have here is ephemeral environments with Kubernetes. So before Kubernetes, when we're talking about Kubernetes and microservices and containers in general, one of the buzzwords that's used all the time is the word ephemeral. Things can be torn down and stood up over and over. So what does that mean? How is that a benefit? So in the pre-Kubernetes world, applications are linked to a specific instance because you're deploying directly to an instance. Now, if you were to shut down an instance, the application would go down. So regardless of traffic needs, you typically would still want to maintain high availability, which requires running multiple, likely underutilized instances. So in addition to this, with fresh instances, taking typically somewhere between 2 to 5 minutes to start up, connect to a load balancer cluster, and start the required services applications, passing health checks, and then start receiving traffic, you had to run over provisioned to prevent your application from being unusable as a new instance scaled up. Now, in a post Kubernetes world, by decoupling the infrastructure and the application further, when leveraging containers and an orchestrator like Kubernetes, you can actually get an additional replica of your application up and running in seconds, not minutes. So you can better use some of the resources you do have running by having Kubernetes schedule different applications on the same instances in the most efficient manner. Think Tetris scaling, bin packing, and such. And you can also allow yourself to scale to zero for applications that don't need to run 24/7, with the ability to scale back up almost instantaneously. So your config maps, secrets, ingress rules, services are already cached in the API server. So your instances are already up and running, already connected to the cluster, with those containers being scheduled and unscheduled seamlessly. So now you can leverage various infrastructure auto scaling tools or processes to create a much more dynamic, efficient, and application driven auto scaling approach. And now I believe, Jeremy, you're going to cover the last of the five secrets.
Yes. So, rounding off this list, we've got cluster upgrades. So, this is usually something that will almost never be, discussed during day zero or day one operations. But let's think about this. So, at face value, upgrading a cluster to a newer version of Kubernetes seems pretty straightforward. There are automated ways to do it. You can manually upgrade the control plane, followed by the data plane. Simple enough, right? So, when you're upgrading to a new version, one thing to think about is all of the objects contained within that cluster are going to automatically be upgraded to their respective newest versions. Now, this might be great in an isolated cluster that's never touched, never updated, never deployed to. But in the real world, there can be some complications here. So, what happens when a developer commits code to a Git repository, kicks off a automated CI/CD pipeline, and then that deployment process attempts to apply an older version of that object? So you're going to get an error. Before you know it, we're in this dependency hell situation where we're one by one trying to identify what parameters need to be updated and what objects, so that way we can deploy our applications. What needs to be added, what's been deprecated, what's not going to work at all. This can quickly get out of hand, even with a single cluster. But as your Kubernetes infrastructure grows and you have different clusters potentially running different versions of Kubernetes, it can be an absolute nightmare. And so, ideally, what we'd want to do is we'd want to know those needs. We'd want to know what exactly has to be changed or updated prior to even upgrading that version of Kubernetes. And so, fortunately, there's tools and things that we can do that will help us with this. There's tools that we can leverage that, thanks to an annotation that Kubernetes applies to objects anytime. There's an annotation called last applied configuration. That annotation is applied every time kubectl apply is ran. And so what it does is it stores API version and configuration metadata for each Kubernetes object in the cluster. If we're to scan our cluster for that annotation across the board, and then we were to compare those that configuration metadata to the new version of Kubernetes we're going to be upgrading to, we can identify what remains unchanged, what can be updated with just a version change, and where there's going to be conflicts that might need to be resolved, as well as where things might need to be completely removed. Now, obviously, we could attempt to do this manually. Again, it would be very tedious. So Devtron actually has an open source tool for this. It's called Silver Surfer. The way you would use it is you can either feed a directory of files that need to be validated, but that I would probably only recommend in the event that all of your clusters are identical in every way. Every object you have is also stored in Git. A more dynamic approach would be to run it as a container within your cluster, allowing it to read objects directly from the cluster so you don't have to worry about potentially missing anything. It can then inform you of any removed, updated, deprecated, or unchanged API versions. But in addition to that, provide a migration path forward. And that way, running a scan proactively, updating the objects prior to upgrading the cluster will ensure that you have a seamless experience when upgrading. So that's the fifth and final secret to unlocking the power of Kubernetes. As you begin to implement these best practices, it can make Kubernetes, again, a more seamless part of your infrastructure that we don't always have to talk about. We don't have to think about. It just works. Ralph, back to you.
Okay, great. So now we will go ahead and go to the Q&A session here. So if anybody has any questions about Kubernetes or beyond, please feel free to enter your question. Okay, I've got one here. Are you seeing deployments of Kubernetes with managed providers or on-premise? So in general, I would say that we see them mostly on managed providers, typically the big three, Amazon's EKS, Google's GKE, and then Azure's AKS. Those are the most common. I definitely will run across an organization running vanilla Kubernetes on premise too, but that's fairly rare. Let me see here.
And I would say one thing to add to that is, in addition to the managed cloud providers, that's a whole cloud discussion. I'd also say another thing that you see a lot is customers, organizations moving more towards managed Kubernetes control planes. So rather than self-managed, where everything's being stood up by the ops team, using something like AKS, GKE, and EKS, allows you to do things like spin up a cluster in minutes, eliminate all of the operation overhead that comes with self-managed, allowing developers to focus on their development instead of also being Kubernetes experts, and then tighter integrations with that underlying infrastructure, with your identity and access management tools and things like that out of the box.
Now, here's another question. What's an average time to build CI/CD pipelines for Kubernetes? That might be a challenging question to answer, Jeremy, just because it can. There's so many variables involved, right?
Yeah, I'd say a couple minutes to a couple months,
Yeah, yeah, that's probably a great range.
Yeah, absolutely. For example, in my first cloud engineering role at Western Governors, we had this brownfield to greenfield, migration, and we had to build pipelines effectively from scratch. And so that involved writing custom scripts, implementing with the cloud provisioning tools we were using, making API calls. Some things were Bash scripted, some were Python, some were in Go. We were kicking off Lambda functions to do all types of things. And that process ended up taking, I want to say, a bit over a year to get everything, automated in that fashion. Then you look at, some of the platforms today. Not going to plug ours too much, but maybe check it out, where you can, effectively upload your code and have a fully automated CI/CD pipeline in a matter of minutes.
Right.
So there's definitely a maturity in the space today to allow developers to, get up and running in minutes.
Okay, great. Oh, so another question, Jeremy. Can you talk a little bit about the upgrade tool mentioned?
Yep. So the upgrade tool is called Silver Surfer. You can find it on Devtron's GitHub account, and using it as a container, which is kind of the route I recommended. What it will do is it will pull that last applied configuration annotation and the respective metadata for every Kubernetes object that is running in your cluster and compare it to a future version of Kubernetes to see, where are things unchanged, where are things being deprecated, where are things being removed, where are things being added, and this allows you to quickly make those changes before upgrading your Kubernetes cluster.
Right.
I don't know if there's a general, chat, Ralph, that you could post a link to it,
Yeah, yeah.
where we have
Let me
the
do
the
that.
code and the README.
Yeah, let me go ahead and do that. And looks like we have one more question. How often have you seen portability being used by users of Kubernetes?
So that's a good question. I guess it depends on what you mean by portability. If we're talking about the clusters themselves, it's really going to come down to uh, how you're deploying. Are you using infrastructure as code? I don't know how portable it could be considered. Now, if we're talking about portabilities of the applications running on Kubernetes, that's a different story. As long as the architecture of the underlying instances aren't changing, then it's pretty easy to have portability of your applications. Your application shouldn't care, where they're running as long as they've got the capacity for it. Anything? Any other thoughts, Ralph, or anything to add
Yeah,
there?
I mean, just in general, I mean, this is a different perspective of it. But certainly, I know that many organizations, when they're negotiating contracts with the different cloud providers, definitely can lean on portability and the ease of migrating from one cloud provider to another. It helps with the negotiation process if you're currently negotiating with one of the cloud providers.
Definitely, and you usually see that decision made, a lot of times by not so much a Kubernetes specific feature, but in terms of things like infrastructure as code and
Right.
managed services that are tied to a particular cloud provider versus more standardized third party options.
Right. Right. Exactly. Exactly. Okay, great. I think that's all the questions we had today. But please feel free to contact either Jeremy or myself. Our emails are pretty simple. They're just our first name, Ralph in my case, at devtron.ai. And Jeremy's is Jeremy at devtron.ai. And then, so if you have any questions around Kubernetes or anything else in general, please don't hesitate to reach out. And as you can see there, we have a QR code so you can follow us on our LinkedIn page. Jeremy, any last thoughts?
No, I can't think of any. Thanks again for
Okay.
having us. And
Yeah.
yeah, look forward to talking with some of you soon.
All right. Thanks, everyone. Appreciate it.